I have to make it start recording and then put it on it. Anyways, okay, so consider the following. Square root of 16 times square root of 9. Well, what's square root of 16?
4.
4. What's square root of 9?
3.
Multiply them together?
12.
You get 12. Okay, now think about this. Square root all over 16 times 9. Well, 16 times 9 is 144. What's square root of 144? 12. So either way, you get the same answer, right? Okay, so that must mean that square root of 16 times square root of 9 is the same thing as square root of all of it, 16 times 9. Okay, so similarly, let's look at this cubed root one. What's the cubed root of negative 8? Negative 2. Okay, what's the cubed root of 27?
3.
You are correct. So those multiplied together get negative 6. Okay, somebody tell me what negative 8 times 27 is.
Negative
216.
Negative 216. Okay, what's the cube root of negative 216?
6. 6, I'm guessing.
It is negative 6.
Yes.
You can do it in the calculator and figure it out.
Well, I was just looking at what this was.
Yeah. So, you can say, same thing, that if you deal with them separately, it's the same thing as dealing with them together underneath square root, right?
Right.
Okay, we can use this to our advantage, and there's a property that talks about this. This is the whole definition thing. It just says that if they have the same index, you can deal with the factors separately or together underneath square root. All right. Okay. So let's do some examples. Can you take the square root of 2? No. Can you take square root of 8?
Yes.
No.
Not
Well, not and get a perfect square. So let's put them together. Square root of, what's 2 times 8? 16 equals 4. Not bad, right?
I like it.
Okay, the next one, again, we can't take the cubed root of those, but what are those multiplied together? What's the square root of negative 125?
I mean, the cubed root?
Cubed root of negative 125 is negative 5. Any questions so far?
So you're just putting them together?
Just putting them together is correct. You're multiplying them together on the inside. Okay, what are those multiplied together?
Negative 16.
What do you get for that?
4i.
4i, but we're not dealing with imaginaries, so right.
Absolutely. Oh.
No real answer.
Oh shoot, because it's
Even root of a negative number. Look at us, we're flying. Okay, it says simplify each expression. Assume that all variables are positive. So that means you don't ever need absolute value symbols. Okay, so you don't have to worry about that because we're assuming everything's positive. All right. We need to break down 72 because it's not a perfect cube. What can we break that down into?
9 and 8.
9 and 8 works. Okay, so that's 3 and 3.
4 and 2.
4 and 2. It's 2 and 2. We're looking for sets of how many?
3.
3. So we have a set of 2s, and then we have our 3 times 3 left over. The 4 we broke down, so we can ignore it. Okay, so outside there'll be a 2. Inside there'll be 3 times 3, which is 9. Okay? Now, what?
Oh, do you still write that 3?
The index? Yes, index has to stay the same through the whole problem. Okay, so x to the 6 and divide that by your index. So 6 over 3. What does that leave you outside? X squared. So that is your answer.
I always forget that you can do that.
I kind of like this, actually. I like the, like, simplifying the
Yeah.
stuff.
Okay, next one, we're doing 4th root of 80. Let's start there, okay. What do you want to break 80 down into?
10 and 8.
10 and 8.
2 and 4.
Okay, so that's what, 5 and 2, 2 and 4, 2 and 2. Looking for sets of 4.
You have two.
The 2s.
Yeah, you have the two sets of them.
Okay, so 2 comes out, and then we still have 4th root of 5. And then we gotta deal with our n. How you wanna deal with the n?
You just have 4, so you bring one in and out, and then one will stay in.
Okay, so you can break it down, you can write it out like this. Whoop, and do the set of 4. Like that. So as Ashlyn said, 1 comes out, 1 stays in. Or if you wanted to, you could have broken it down and said n and then n to the 4th. Okay, and know that you can divide that one by 4, and that's the one that comes out, and that's the one that stays. Either way, if you want to think about it. This is probably like simpler to think about, unless you have like n to the 3,000, then you might not want to write them all out. Okay. Okay. Any questions on those? No? We get a little more complicated with example 3. We have to multiply and simplify. Again, we're assuming all variables are positive. So no absolute value is needed. So how you want to deal with it? Do you want to combine them first? 54 times 5. 270. Okay. What about when we multiply x squared and x cubed?
X to the 5th.
X to the 5th. They each have a base, so just add the exponents. Okay, so then what do you get for your y?
Y to the 7.
Y to the 7th. All right. Let's break it down.
It's gone.
What do you want to break 270 down into?
54 and 5.
30 and 9. Sorry, every time. Okay, 9 breaks down to 3 and 3. So 30, I'm going to do 10 and 3. There's my 3's. Can I break 10 down in anything that can be cubed? No. Okay, so we know a 3 is on the outside, and what's on the inside?
Oh, 10.
A 10 still. Okay. What about
You can have,
You can
you'll
take
have
that.
3x is on the outside and then 2 on the inside.
X squared is on the inside.
Okay, so 3 of them make a set and we mark them outside, and then 2 left over makes x squared on the inside. That's what you're saying, right? 2 sets of y's and then one of them left over. So that's your answer. I'm just thinking about the whole dividing the exponent thing. So say we take that y, and we're doing 7. And if we divide it by 3, okay, what's 7 divided by 3? How many times does 3 go into 7? 2, and what would your remainder be? Remainder 1. So the 2 go outside, so y squared, and the remainder 1 stays inside, y by itself. I just kind of thought of that. It works. If you want to do it that way. Okay, that's today's notes.